everyone! In today's video we're going to be going over the mixed factoring practice that you guys had from last week. So we're just going to go over each of the answers and just hopefully you guys will notice that you're starting to get more comfortable with the process, knowing which method to use and going about actually using each of the methods. So let's start with the first problem. The first problem that we need to factor is n squared minus 3n minus 28. Since we do not have a number in front of our n squared or x squared term, since the coefficient is 1, we can just go about the normal trinomial method. So it needs to multiply to negative 28 are factors, but it needs to add to negative 3. So since it needs to add to a negative number, I know that the larger factor has to be negative. But let's just try to think of some numbers that would multiply to 28. So I could do 2 and 14. I could do, let's say, 7 and 4. The larger number has to be negative because I want the sum to be a negative number. 2 plus negative 14 would be negative 12. So that's not good. But negative 7 plus 4 would be negative 3, which is what we want. So our solution is going to be n minus 7 and n plus 4. For the next problem, we have 2x squared plus 12x plus 18. So this is once again a trinomial, but this time we have a coefficient in front of our x squared term. So the first thing we need to think, is there a GCF? Is there a common factor that we can pull out from all of the terms? And the best common factor to test would be the coefficient in front of the x squared. So can I pull out a 2 from a 12? Can I pull out a 2 from an 18? 2 is the greatest common factor, so I'm going to pull the 2 out. So this is going to be x squared. 2 times what will give me 12x? That would be 6x. 2 times what will give me 18? That would be 9. Now I can ignore the 2 and go about this problem like normal. So I need to multiply to a positive, and it needs to add to a positive. So my factors need to both be positive. So my 2 is going to be on the outside, and it's going to be x plus 3 and x plus 3. Since this is the same factor twice, I can rewrite this as 2 times x plus 3 squared. This is definitely not a trinomial because recall tri means 3 and we only have 2 terms. So you want to check and see if there's a greatest common factor. The answer is yes, except it might be a little hard for you guys to see this. R squared can be rewritten as r times r. So saying you have 2 r's. And the minus 2r is just minus 2r. So you should be able to see there's definitely an r from each of these terms. So I'm going to pull the r out. If I pull one r out of this, I'm left with one r left for that term. And if I remove the r here, I'm left with the 2. There's nothing else to factor, so you're done. For my next problem, this is again a trinomial. But we have a coefficient that's not 1 in front of our m squared term. So I need to see if I can factor that out to begin with. Is there a common GCF? So my first instinct would be to pull out a 10. However, 10 does not go into 46 evenly. 10 does not go into 48 evenly. So now you need to think about another number you can pull out. 10 is even. 46 is even, 48 is even. So the greatest common factor I can pull out will be a 2. It's okay if you can't pull out the whole coefficient in front, just pull out what you can. So now I need to make this to be 10m squared. So 2 times 5m squared will multiply back and give me 10m squared. 2 times what will give me 46? That's going to be negative 23m. 2 times what will give me 48? This will be plus 24. So now this is looking like what we're used to. I'm going to ignore the 2 out front, and now I'm going to look at how to factor this trinomial. Again, this trinomial does not have a coefficient of 1. So I need to use the a times c method. The a times c method says I need to take 5 times 24. 5 times 24 gives me 120. So now I need to think of numbers that will multiply and give me 120, but add and give me negative 23. Since I'm multiplying to a positive number, but adding to a negative number, both of my factors have to be positive, or both of my factors need to be negative. But if you want to add to a negative, you would need both of your factors to be negative. So we're going to think of some numbers that can multiply to 120. I could have, let's say, negative 6 and negative 20, but that's not going to add to negative 23. I could have negative 30 times negative 4, but that's not going to add to negative 23. I could do negative 8 and negative 15. That will add to negative 23. Now what you want to do is rewrite these terms in place of your negative 23m. So I'm going to write 2 parentheses 5m squared minus 8m minus 15m plus 24. So all I did at this moment was rewrite the negative 23m as these two terms. Now I'm going to go ahead and do factor by grouping. So what's in common between 5m squared and negative 8m and m? If I pull out an m from this, I'm left with 5m. If I pull out an m from this, I'm left with minus 8. Now I'm going to look over here and see what goes into 15 and 24. What number would go into both? That would be a minus 3. Negative 3 times what is 15? That would be 5m. And then it would be negative 8. Negative 3 times 5m is negative 15m. Negative 3 times negative 8 is 24. Remember I said whenever you go about the A times C process, this should be repeated. So I still have this 2 out in front. I have an m minus 3 left. And I have a common factor of 5m minus 8. My next problem here would not be a trinomial. Once again, we only have 2 terms, not 3. So now I'm going to think and see, can I pull out a common factor? Is there any number that goes into both 25 and 16? And the answer to that is no. So your last approach is to see, is this a difference of perfect squares? Difference means subtraction. Perfect squares means you can take the square root of every term. So the square root of 25 is 5. The square root of v squared is v, because v times v is v squared. The square root of 16 is 4. And the way these work is you have one set that is positive and one set that is negative. And if you did a box and multiplied this out, you can check and see that that would work. All right, this next problem. Once again, we have a trinomial. We have 3 terms. First question, is there a common factor that we can pull out from all of them? Does 7 go into 12 and 4? No. So this is again the A times C method. So my A times C, I'm going to do 7 times negative 4, and that's negative 28. I want to multiply to a negative, and I want to add to a negative. So one of my terms needs to be negative to multiply to a negative. And since I want it to sum to a negative number, more specifically my greater number has to be negative. So I know what factors and what would multiply to 28. So again, I have 7 and negative 4, but let's say I have 2 and 14. My negative term would be the larger one. 2 times negative 14 is negative 28. 2 plus negative 14 is negative 12. I'm going to put these terms in place for the negative 12. So I'm going to rewrite the problem as 7x squared plus 2x minus 14x minus 4. Now I'm going to factor out a common factor, and I'm going to do factor by grouping. So what's in common between 7x squared and positive 2x and x? So I'd be left with 7x plus 2. What's in common between a 14 and a 4? Their greatest common factor is 2. But I'm going to pull out the negative with it. Okay? So this is going to be left with 7x, because 2 times 7x will be negative 14x. And then this is going to also be a plus 2, because negative 2 times 2 would be negative 4. Had I have written a plus, like I was originally going to, this would have had to have been a negative 7x, and then these would not have matched. So that's why I altered it. Now I'm going to pull out the x minus 2 and the 7x plus 2. For this next problem, this would not be a trinomial again, only 2 terms. Can I pull out a common factor? No, 4 doesn't go into 9. So I'm left, is it a difference of perfect squares? The square root of every single term. The square root of 4 is 2. The square root of x squared is x. The square root of 9 is 3. Repeat this set with a negative. All right, for my final problem, we have another trinomial. I can't pull out 10 from everything, so I have another trinomial where I have no greatest common factor. Therefore, it's the a times c method. So I'm going to do 10 times 4, which is 40. I want to multiply to a positive 40, but I want to add to a negative 13. Therefore, both of my factors need to be negative. So if I just think about some numbers that would multiply to 40, let's see what I can think of. So let's say I had a negative 5 times a negative 8. That would be positive 40. And negative 5 plus negative 8, that would add to negative 13. So this would work. So I'm going to write this in place of the negative 13x. So it's going to be 10x squared minus 5x minus 8x plus 4. Once again, I'm going to do factor by grouping. What's in common between these two pairs? Definitely an x, but even larger, I can pull out a 5. 5x times what is 10x squared? 2x, because 5 times 2 is 10. X times x is x squared. 5x times negative 1 will give you the negative 5x. Now for the next set, what's in common with both? The 4. It's always good to pull out the negative. Negative 4 times 2x will make a negative 8x. And negative 4 times a negative 1, because a negative times a negative will give me a positive. So then I'm left with 5x minus 4 and 2x minus 1.